Hello, good morning. I am Khaja Asifullah, lecturer in chemistry from Govt Degree College, Falaknuma, Hyderabad. In chemistry, today I will discuss with you chemistry of complexes, that is coordination compounds. This is part 3, means this is the third lesson in the series. In the previous lessons, we discussed about what the complexes are and what are different terms, etc. Today in part 3rd, we will discuss about how to name a complex compound or a coordination compound. It is a new system designed by Alfred, Werner, a Nobel Prize winner, and IUPAC, that is the Inorganic Union of Pure and Applied Chemistry. In 1957, this system was proposed to name coordination compounds or complexes, which has few rules which are as follows. To name a compound called as coordination compound or a complex, first we will name or write the name of positive part or cation of the complex, followed by the negative part or anion. For example, in the compound whose formula is CO NH3 taken 6 times Cl3, this compound will be named as hexamine cobalt 3 chloride. Chloride is an anion, therefore it will be, or its name will be written after the name of cation or the name of this sphere called as coordination sphere or complex ion. Here the complex ion or the coordination sphere has positive charge, therefore its name will be written first. And in this we have a metal atom or ion, cobalt ion, and 6 ligands are attached to this metal ion. All are ammonia molecules, these are neutral molecules. So we will write first the name of this ligand, and before that how many ligand molecules are there in this compound or in this coordination sphere. 6 means hexa, amine, that is the name of ammonia, and cobalt is the metal ion or element, and here we are writing its oxidation state or oxidation number or valency, that is the valency of cobalt. Similarly, in this compound whose formula is Cr H2O4 times Cl2 Cl. Again Cl, that is chlorine, is in anionic form or it is a chloride ion. So it will be written at the end of the name of the compound. And before that, we have to write the name of this sphere called as coordination sphere or complex ion. This complex ion is in cationic form and it consists of three things. First one is chromium. It is a metal ion to which 6 ligands are attached. But all these ion or molecules are not of the same type. 4 molecules of water and 2 ions of chlorine or chloride ions. Here, all these 6 are acting as ligands. So we are writing here the name of ligands because first it is neutral, and also when we write in alphabetical order, later we will learn all those things. This will come first. For water, we will write aqua. So it is start from A. Therefore, before chlorine, that is C, we have to write the name of water. How many molecules of water are there? 4, tetra. And how many chloride ions are there? 2 inside the sphere. Outside the sphere, 1 chloride is there. Here it is having 4 and it is having 2. So tetra, aquo, dichloro, chromium. Then the oxidation state of chromium, again it is 3 here, chloride. Now this oxidation state 3 is written in Roman numerals. So with these two names are examples of compounds in which we have written names of these complexes. We can understand how to write, but we have to follow the rules. Second rule, in case of non-ionic or molecular species, one word is given to the coordination compounds. In the previous examples, we had a cation and an anion. If a complex compound exists in a molecular form instead of ionic form, okay, or it is non-ionic, you can say non-ionic form or molecular, then we have to write the name of compound as one word. So we cannot write this chloride after the name of coordination sphere here, because this chlorine is again inside the coordination sphere, which serve as a ligand. So both ligands, ammonia and chloride, are acting as ligands. So this is central metal ion, cobalt, ammonia, a ligand, chloride, again a ligand. Both the ligands have three molecules or ions. So tri we can use here. If one molecule or one ion is there, mono, di, or 2, 3, tri. So it is again written first because in alphabetical order, when we write the name, A come first, then C. A for amine, which stands for ammonia, and chloro for chlorine. So it is triamine, trichloro, cobalt 3. Again, this is oxidation state of cobalt. So cobalt exists in +3 oxidation state. Now this is also a neutral compound, or it exists in molecular form. This we have to write as a single word. So we can write it as first ligand. What is the ligand? Carbonyl group. How many carbonyl groups are attached? 4. Therefore, for 4 we use tetra. CO means carbonyl, and I means nickel. And because this is a molecule, so its oxidation state will be 0. Therefore, oxidation state of nickel will also be 0. Therefore, tetra, carbonyl, nickel, 0. 0 stand for oxidation state. This is a compound again having molecular form, or it is non-ionizable or non-ionic compound, non-ionizable in water. So here platinum is the metal ion or metal used. Chlorine and ammonia are again the ligands. Both have two atoms, molecules or ions. Therefore, for two we use di. First, ammonia will be written, or the name of ammonia, then comes the name of chlorine or chloride. For ammonia, we write amine. For chloride, we write chloro. So, diamine, dichloro, platinum 2 means here platinum is in +2 oxidation state. So, this is the way we write the names of complexes. Next rule is naming of the coordination sphere. In the above examples, we have written the names, but till that stage, we were discussing about the rules, how to write the ions or molecules. Now, if a coordination compound or a complex exists in an ionic form, then how to write the name of coordination sphere. For that also, we have certain rules, or Werner framed certain rules, we have to follow them. First rule is, while naming a coordination sphere, the ligand are named first and then the metal. In the previous examples also, you have seen inside the coordination sphere, which is non-ionizable, we have two things, a ligand and a metal atom or metal ion. Ligand or ligands, because sometimes the coordination number or secondary valency of a metal is satisfied by one ligand or sometimes more than one ligand. So whatever it may be, the ligand's name have to be written first, then the metal name of the metal ion. So following points we have to follow while naming the ligand and the central metal ion. Now, inside the coordination sphere, we have a metal atom or metal ion called as central metal ion and a ligand. So first, rules for writing the names of ligands. We know that ligand is a species which may be a neutral molecule or sometimes ion again a positive ion or negative ion. Then how to write the name? We have certain rules to write the name of these ligands. Example, if we have organic molecules, we have to write names of those as, if we have C5H5N pyridine, NH2, CH2, CH2, NH2, it has to be written as ethylene diamine. Then C6H5 taken 3 times P. 3 means tri. The name of this is phenyl. So triphenyl phosphine. It is the derivative of phosphine. PH3 is called phosphine. And we have replaced hydrogens with this rings. One hydrogen less than C6H5, that is benzene. So all 3 hydrogens are replaced by 3 rings of benzene. Therefore, it is phenyl and triphenyl phosphine. Now, if Neutral ligands are named. How to write the name of neutral ligand? These are named differently and not as a molecule. For example, H2O, we call it as water, but here we have to name H2O as either as aqua or as aqua, but generally we write aquo. For NH3, that is ammonia, we use amine. For molecule like CO, we write carbonyl. For a molecule like NO, nitrosyl is used. Now, there are negative ions also. These negative ions serve as ligand to form complexes. If we have this a ligand with negative charge or ion, how to name? For Cl minus, that is chloride, we have to write chloro. Generally, it ends at O. At the end, we use O. Chloro, sulfato, nitro, nitrito. NO2 means nitro. ONO minus means nitrito. OH minus hydroxo. Hydroxy to hydroxo. NH2 amido. NH2 minus. NH2 minus means two negative charges. Imido. Oxalate ion. Oxalato. Nitrate ion. Nitrato. Carbonate ion. Carbonato. In this way, we have to use these while we write the name of the ligand if it is a negative ion, chloro, sulfato, nitro, etc. Fourth in this is we are trying to understand the rules to write the name of ligand. Here, ligand may exist in neutral molecular form or negatively charged. Now, the third one we are taking it as positive ligand. Means it is a positive ion which serves as a ligand. Here, when a positive ion acts as a ligand, the name of the ligand should end as EM. EM. NO2 plus nitronium. NO plus nitrosonium. NH2, NH3 plus. NH2, NH3 plus will be written as hydrazinium. Hydrazine, hydrazinium. Next rule is, again it is also for ligand, that means naming a ligand. We may have more than one ligand, as we have seen in one of the example here, Cl, NH3. NH3, Cl. In 2-3 examples, we have seen that more than one type of ligand is present. Therefore, for that case also, or in this case, again, when there are several ligands in the coordination sphere, these are listed or named in alphabetical order. We have to see with which alphabet the name of ligand starts. That means in ABCD, in the order of ABCD. For example, names of ligand starting with A are amine for NH3, aquo for H2O, or bromo, chloro, nitro for anions, etc. If we consider this, the order is A, then B, then C, then N. Or if it is sulfate, sulfato with S, the sulfato will come after this. If carbonato, carbonato will come before chlorine with a Ca, not, and then CH. So in case a simple ligand like Cl minus, etc. are present in more than one number, sometimes a ligand may be present in more than one number. Means here, see, this group is there, but how many such groups are there? 3. So we can write tri like that. So when we have more than one ligand, same ligand, then we have to use mono, di like that. So for 2 such ligand, we use di. Di, if we have 2 Cl minus, dichloro. For 3, tri. Tetra means 4 such atoms or molecules or ions are there. So 2 Cl minus, dichloro. 4 H2O, tetraaquo. 6 NH3, hexamine, etc. Now, on the other hand, the number of other ligands which already have prefixes like di, tri, tetra, etc. in their names, as in the case of ethylene diamine, it is indicated by bis, tris, tetrakis, etc. What is the meaning of this rule? If mono, di, tri, tetra, etc. is already there in the name of the ligand, there it will be used as prefix. Then now while you name the ligand in the naming of coordination compounds, if 2 such molecules or ions are there, we use bis. Why? Because already di will be there in its name. Ethylene diamine. Similarly, if we have 3 or tri in the name of it as a prefix, then we will use tris. For 4, we use tetrakis. So we will not use di, tri, tetra again while we name the coordination compound. Instead of that, we can use bis, tris, tetrakis, etc. Next rule for naming the compound: when the coordination sphere is either a cation or a neutral molecule, the name of central metal atom remains as such, and the oxidation state or oxidation number or valency of the metal is shown in the bracket immediately following the name of the metal. So as we know, the coordination sphere may exist either in neutral molecular form or as a cationic form or as anionic form. So here, when it is a neutral molecule or in cationic form, the name of metal will be as it is. For example, cobalt. It will be written as cobalt. Or chromium, it will be written as chromium, but we have to write the oxidation number, or we have to show the oxidation number of that metal atom or ion in bracket, and that should be written in Roman numerals, as we had here in one of the examples: diamine, dichloro, platinum, 2. triamine, trichloro, cobalt 3. In this way, are tetra, carbonyl, nickel 0. In this way, we have to write the name of metal as it is, and then we have to show the oxidation state of the metal. Here also we have certain examples. CONH3 taken 3 times. Cl3, its name will be, first we have to write this ligand with the 3 molecules, therefore triamine. Again, this ligand with 3 ions, trichloro, cobalt 3. Here 3 is the oxidation state of cobalt. Here tetracarbonyl nickel 0. It is the oxidation state of nickel in this compound. PtCl2NH3 taken twice because 2 ammonia molecules are there, diamine. 2 Cl minus are acting as ligand, therefore dichloro. Pt means platinum. Its name is written as it is, no change in the name. And then oxidation state of platinum, here it exists as +2, but here we will not write as +2, but it is Roman numeral. Similarly, hexamine, cobalt 3 chloride. These 3 examples are for molecular state or non-ionic. This is cationic form. This is a cationic form. Here it forms cation and these will form anions. Therefore, for both these cases, molecular or cationic, we will write the name of metal as it is and then oxidation state. Another rule is when the coordination sphere is anion, instead of a molecule or cationic form, we have anionic form, or it is present in anion as an anion. Then the name of metal will end at 8. We have to add ATE to the name of metal. Okay. So the name of metal atom ends in 8. Then oxidation state. We have to write the name of the metal and then we have to add ATE. Then we have to write or show the oxidation state of that metal again in Roman letters or Roman numerals. Then the oxidation state or number of the metal is shown in the bracket immediately. These are few examples again. K3CO NO2 6 times. Here, in this case, potassium, which is outside the coordination sphere, form cation. It will form an ion with positive charge, therefore cation. With +1 charge and 3 cations are there, 3 into +1 means +3. So there will be -3 charge here. 3 negative charges will be there. In total, the coordination sphere has minus charge or negatively charged, or it is in anionic form. So the name, first we have to name, you have to remember this. First we have to name the cation, then the anion. Coordination sphere is anion and here it is cation. So write potassium first, then hexa nitro, because NO2 is present, therefore nitro, hexa nitro. The metal atom is cobalt, but we had to add this suffix and the suffix is 8, 80. So the total name is potassium hexanitro cobaltate, and then oxidation state followed by the oxidation state plus 3. This is one more example in which Na3FeCN taken 5 times NO. Again here there are two different ligands. One is Cn minus and the other is molecule of NO. NO molecule and Cn minus anion. No, whatever it may be. Na means it will form cation. Each Na will have one positive charge. 3 Na will have 3 positive charges, and there will be 3 negative charges here. Okay. Then the coordination sphere is anion, or it is in anionic form. Therefore, to write the name of this compound, we have to write first the cation sodium, then cyano, C comes first, therefore cyano, then comes nitrosyl, therefore N comes after C, therefore sodium pentacyano nitrosyl ferrous to ferrate. This name of metal ferrous will be written as ferrate. We have to add ATE, and then the oxidation state the metal. One more rule says that if the complex is having 2 or more metal atoms, the complex sometimes may have 2 or more metal atoms. Sometimes it happens that a complex may have more than one metal atom, then it is called polynuclear. Okay, if a complex has more than one metal inside the coordination sphere, not outside, because here there are 2 metal atoms, but inside the coordination sphere only one metal is present. Outside there is one more, but it is ionizable. It forms cation. Similarly, in this case also, sodium is present, but it forms cation. Therefore, inside the sphere, which is non-ionizable, only one metal is present in this as well as in this case. But sometimes inside the coordination sphere or complex ion, we may have 2 or more metal atoms. Then it is called polynuclear coordination compound or complex. Now the ligand which connect the 2 metal atoms are called bridge atoms. It will form a bridge ligand which connect 2 atoms, means atoms of 2 different metals form bridge, or it is a bridge group. These are preceded by Greek letter mu, means we have to write mu before the name of each different kind of bridging group. So we have to write mu before the ligand who is forming a bridge, or it is called bridging group. So in this example, in which we have a compound octaco, means 8 water molecules are there, and 2 hydroxo, means OH minus ions are there, and then iron is the metal which is having the hydroxy group will form a bridge with this, and then sulfate. Sulfate is anion. This is cation. Complex ion is cation. So we are writing the name as octaco mu dihydroxo diiron sulfate. Diiron 3 sulfate. Here diiron means 2 metal atoms are there. Hydroxo means two OH minus groups are there, and mu means OH minus will link these two as a bridge, and then octaco means 8 water molecules are there, and 3 is for the to represent the oxidation state or oxidation number or valency of iron. One more example which we have as octamine, mu, amido, nitrocobalt, 3 nitrate. 8 amine groups are there, and amido group forms a bridging group with cobalt. And then the oxidation state of cobalt is 3, and nitrate is the anion of the complex, which get ionized in water, and this part will not get ionized, therefore it is called complex ion or coordination sphere. And that coordination sphere has 2 metal atoms, both are of iron. Now, one more rule is there. In case of a unidentate ligand contains more than one donor atom, it is called ambidentate ligand also. So a unidentate ligand containing more than one donor atom is called ambidentate ligand. In the last class or in previous class, we discussed about this types of ligand we learned in that class. So its point of attachment with the central atom is designated by the symbol in italics of the donor atom after the name of the ligand. Since this unidentate ligand has 2 or more donor atoms, if that is the case, we have to show which atom is attached actually. Therefore, its point of attachment with the central atom is designated with the symbol of the donor atom after the name of the ligand. For example, in this case, K3COCNS taken 6 times, the cation, which is potassium, its name will be written first potassium. Hexa means 6 ligands are there, or 6 ligand molecules are there. Hexa, CNS, cyanato, N. N is a donor atom, not C or S. Okay, out of carbon, nitrogen, and sulfur atom, nitrogen is donating a pair of electron, or it is a donor atom. Therefore, it is written here. So potassium, hexacyanato, N cobalt 3. Here cobalt exists in +3 form or oxidation state. Why? Because 3 potassium ions are there. To neutralize 3 plus ions, we have 6 negative ions. So after neutralizing 6 positive charges, we will remain with 3 negative charges, and this will be neutralized with 3 positive charges of cobalt. So the oxidation state of cobalt is +3. It is written as 3. So this N, in this particular rule, we have to stress on this N, which is the point of attachment or atom which is attached to the metal. Next is, when we have geometric isomers, then we have to write them as cis and trans, depending upon whether similar groups are on the same side or on the opposite side. What is the meaning? Geometric isomers are those isomers in which there will be 2 similar groups. Then we will be having 2 different cases. These 2 similar groups may be on the same side or on the opposite sides. If they are on the same side, we will write it as cis. And if they are on the opposite side, then we will write trans. Okay. We may be having one more type of isomer, which are optically active isomers. In geometrical isomerism, we have two types of isomers, cis and trans. Similarly, in optically active isomers, again we will be having two types. Actually, optically active isomers rotate plane polarized light either in clockwise direction or in anti-clockwise direction, or to the right direction or to left direction. If it is right direction, dextro, left, levo, or we assign plus sign or minus sign, and L for levo, D for dextro rotatory group. Okay, we have to assign either plus sign or D for dextro, and either minus sign or L for levo rotatory groups. It may be a levo rotatory group or dextro rotatory group. Therefore, plus RD for dextro, minus RL for levo. Then comes one more rule called as complicated ligands. Here, when complicated ligands are customarily denoted by abbreviations in complexes. For example, ethylene diamine is commonly written as EN. Instead of writing the whole name, we write it as EN. So, in the case of complicated ligands, we can use this. Few more examples which can illustrate the nomenclature of IUPAC system of naming. We have a cation with 4 ligands here. Cu is metal ion or central metal ion, and ligand ammonia has 4 molecules, means this is central metal ion and ligand, which constitute the coordination sphere or complex ion. And this complex ions has a positive charge. 2 positive charges are there. Either it is positive +1 or +2. It is a cation. So we have to write the name as tetramine copper 2. So instead of +2, we write Roman numeral, and it is ion. Therefore, now it is a non-ionic or molecular ligand. It has name. How many ammonia molecules are there? 2. So diamine. How many chloride are there? 2, which are serving as ligand, dichloro. The name of metal is platinum, and the oxidation state, because of these 2 chloride for platinum, is +2. Why? Cl minus means 1 negative charge. 2 such groups means 2 into -1 -2. That should be satisfied with this. So its oxidation state will be +2. Therefore, we write 2. Here, this is anionic, and this is cation. This is anion. Then the coordination sphere is in anionic form, or it will form anion, and this metal forms at cation. So it is potassium cyanoargentate. I think you remember that when complex ion exists as anion, you have to write ate as suffix with the name of metal atom. Silver means argentum. We write it as argentate by adding the suffix ate. Therefore, the name of this compound is potassium dicyanoargentate, and the oxidation state of silver is 1. Why 1? Because there are 2 cyanides are there, means -1 into 2, -2. 1 charge is neutralized by K plus, 1 by Ag plus. Therefore, Ag exists in +1 oxidation state. One more is Cr En taken thrice Cl3. Here it is cationic coordination sphere, as chloride is anion. So complex ion or coordination sphere will have negative charge, therefore, positive charge, and chloride anion. So this cation will be written first. In that we have ligand as ethylene diamine, and its 3 molecules are present. Therefore, tris ethylene diamine chromium 3 chloride. Now here, how many rules and what are the rules we are following? The ethylene diamine, this ligand has di as, already di is present, diamine. Okay, 2 groups of amine are there, it indicates. It is used as prefix in the name. Therefore, we cannot use here try again, because it may confuse. Therefore, it may create confusion. Therefore, we write 3 as tris. This was one of the rules we have gone through, which says that when a prefix is there, like di, tri, etc., in the name of ligand already, then we have to use bis, tris, tetrakis, etc. Therefore, this is the reason why we are writing tris ethylene diamine, then the name of central metal atom chromium, then the oxidation state of chromium, that is 3 here, chloride, which is the name of anion. Now, why the oxidation state of chromium is 3 here? Because 3 into -1 oxidation state of Cl, minus 3 into 1, 3. This -3 will be neutralized by the +3 oxidation state of chromium. Therefore, 3 minus 3 is 0. The molecule will have 0 charge. Therefore, its oxidation state is +3. Totally, tris ethylene diamine chromium 3 chloride. So, with this, we will end today's lesson, because in the next class, we will be dealing with the theories which can explain the complexes, their behavior, their chemical behavior, their chemical structure, or the geometry, etc. We have different theories to explain the nature, chemical nature, and the behavior of nature, and also the shapes and geometry of the complexes. We will discuss in the next class or next part of the lesson. So you have to be in touch with that. So today's lesson we will end here, or we will stop here. Thank you for watching and listening. Thank you, one and all.